but I'm not dreaming anymore. All that I know is I'm falling.
Okay, so here's problem number 1. We have a tank which contains 100 gallons of pure water, and at time equals 0, a solution containing 0.2 pounds of sugar per gallon enters the tank at 3 gallons per minute. A drain also allows solution to exit at 3 gallons per minute. Okay, so part A, because there's a part A, B, and C, is what's the sugar content in the tank after 20 minutes? So the first thing we have to do is, well, we don't have to draw a picture, but I'm just going to draw a picture just so we can kind of visualize what's going on, okay? So we have some tank with solution in it, all right? And there's solution entering, like a new solution, which is 0.2 pounds of sugar per gallon. That's its concentration. So some kind of fluid is entering and some fluid is exiting as well, all right? Both at the volume rate of 3 gallons per minute. So the volume inside the tank is constant, alrighty? It's a constant 100 gallons. Alright, so for this problem, let's say that y of t represents the sugar content, okay? Sugar content after time t, in the tank, that is, after t minutes, okay? And therefore, y prime of t, also known as dy dt, is the rate of change of this sugar content, okay? So just to identify some things here. So the rate of change of the sugar content. Alrighty, and then so y prime of t, so y prime is equal to rate in of the sugar minus rate out of sugar. Okay, so again we have to identify what is the rate in and how do you represent rate out. So rate in this case, let's do it on this slide here. So this is going to be equal to the volume of solution entering, or the volume rate, right? So 3 gallons per 1 minute. And then times the concentration of that solution entering. So that would be, in this case, 0.2 pounds of sugar per 1 gallon. Okay? So if we solve for that, we just get 0.6 and pounds per minute. So this is how much sugar is entering per minute. Okay? And now let's do rate out on the next slide. So now for rate out, this is a little bit more tricky, right? So rate out is equal to the volume rate going out, so that again would be 3 gallons per 1 minute. But this time the concentration is a little bit trickier, and so this is going to be the sugar content over the total volume in the tank. So this is going to be y of t, which represents the sugar content at any given time, right? So this many pounds per, and our total volume in the tank is 100 gallons at any given time. Okay, so this is just simplified is 3 over 100 times y. And this is pounds per minute, because the gallons cancel out, right? Okay, so now we have that, and our differential equation now looks like y prime is equal to 0.6 minus this 3y over 100, and this is in, the units are pounds per minute, but those aren't really that necessary, okay? We just know that. Alrighty, so let's solve for this. Let's solve our ODE now. So our A of t is equal to whatever the coefficient of our original function is, which is y. So that would be negative 3 over 100. Okay, and if we move this whole term to the left side, like we're supposed to do with the linear equation, we're going to get this equation here, which is equal to 0.6 now. Okay, now we're going to solve for our integrating factor, which is mu of t, which is equal to e to the negative integral of whatever our A of t function was. Okay, so again, we have something like e to the, and a negative, so we have positive 3 over 100 dt. So this is going to be equal to e to the 3t over 100. This is our integrating factor here, okay? So we're just going to multiply our entire equation, so that means both sides, by this integrating factor, so that we can simplify that left side and consolidate it into one term, okay? A single term here. So we have something like this on the left side, okay? And on the right side, we're just left with 0.6 times e to the 3t divided by 100. Alrighty, and we'll continue this on the next slide where we'll integrate and do our thing, okay? Alrighty, so we have e to the 3t over 100 times y, and then everything is in the inside parentheses and with a prime. Right, and then this is equal to 0.6 times e to the 3t over 100. and we're going to integrate with respect to t, and we're going to integrate with respect to t on the right side as well. So on the left side, we just get out that whatever's inside the parentheses, okay? And then on the right side, we have 0.6, and then times this 100 over 3, and then times that term, the e term. And of course we have our plus c because we had an indefinite integral here. So the right side can simplify. This will become 0.2 times 100. So this whole thing is a 20 in front. All right, so we have 20 e to the 3t over 100 plus c, and this is equal to our e to the 3t over 100 times y. So if we simplify this last step, we're just going to divide by this term on both sides. So we get y of t is equal to 20 plus c times e to the negative 3t over 100. Okay, so this is our general solution, and in order to find the particular solution, we just have to utilize the fact that y of 0 is equal to 0, which again means that at time 0, when we have only pure water in the tank, our sugar content in the tank is 0. We have 0 pounds of sugar in the tank, okay? So if we plug that in, we get y of 0 should be equal to 0, which when we plug in our t was equal to 0, we get 20 plus c e to the 0. So c then has to equal a negative 20. All right, so our particular solution is y of t is equal to 20 minus a 20 e to the negative 3t divided by 100. And that 100 looks funny, so let me rewrite that real quick. Okay, so e to the negative 3t divided by 100. Alright, so the last part to this problem is we were supposed to find what is our sugar content after 20 minutes. So let's do that. Wrap it up on the next slide. So y of 20, because we're going to plug in 20, because that's time, right? Should be equal to, when we plug in a 20, so 20 minus 20, these are all part of the formula, and then e to the negative 3, and in for t, we're plugging in a 20 here, and then 100, okay? So this is going to be, when we cancel those out, this is like to the negative 3 over 5. So this is 20 minus 20e to the negative 0.6. And if you plug this into a calculator, you'll get something around the number of 9.038 pounds. And you can always put of sugar. Okay, that'll be the sugar content after 20 minutes. Okay, so here's part B. It's asking when will the sugar content reach 15 pounds? So here we kind of have to work backwards, but nonetheless we're going to use our differential equation. Okay, well not our differential equation, but actually the solution to that equation, because we have our solution gives us the sugar content, the formula for that. So our y of t we found was equal to 20 minus 20e to the negative 3t over 100. And the reason that we're using our particular solution, in the sense that we don't have like a plus c here or anything, is because we still have our same initial condition, right? Our initial condition was y of 0 is equal to 0. We're still working with our same initial value problem, okay? So we're going to use this guy, and it says when will the sugar, so it's asking for a time. So we're trying to solve for t such that our y of t is equal to 15 pounds, okay? So what we're going to do is actually just plug this 15 into the left side and solve for t. So we have 15 is equal to 20 minus 20e to the negative 3t over 100. We're going to switch some things around, so we'll subtract the 15 and we'll add this term on both sides. Okay, so let's do that real quick. All in one go. 3t over 100. Okay, so those cancel out and these cancel out, and we get 20e to the negative 3t over 100 is equal to a 5. If we divide by 20 on both sides, we just get a 1 over 4 on the right side, okay? So we have e to the negative 3t over 100 is equal to 1 over 4. So we're just going to ln both sides, cancel out that e, and this, I'll just move up here, okay? So now we have negative 3t over 100. That comes down on the left side. And on the right side, we just have this ln of 1 over 4. Okay? So now that we have that, all we're going to do is multiply by this reciprocal of that fraction. So t is then going to be equal to negative 100 over 3 times ln of 1 over 4. And if you plug this into a calculator, we get that t is equal to about 46.21 minutes. Okay, so that's about how long it will take for our sugar content in the tank to reach 15 pounds. Okay, now for the last part of this problem. Part C, it says, what will the eventual sugar content in the tank be? So this question is implying that eventual, this says a lot right here, that means that we're going to be studying what's happening to our sugar content as t goes to infinity. And again, the function which represents our sugar content at any time is y of t. So we're trying to examine, okay, what's going to happen to y of t as our t is going to infinity, okay? And in order to figure this out, we're going to take the limit as t goes to infinity of our function y of t. And so for this, we're just going to plug in what is the representation of our function, of our sugar content, and that would be our 20 minus 20 e to the negative 3t over 100. Okay, and let me just rewrite this in a little different way. So this is like limit as t goes to infinity of 20 minus 20 over e to the 3t over 100, right? Because I just moved the negative exponent thing to the bottom. Okay, so when we plug in infinity, we get 20 minus 20 over e to the basically infinity. So this quantity here has something really huge on the bottom. So this kind of zeroes out, okay? So we're going to get eventually that this will just be an exact 20 pounds. This is where our sugar content is headed as time heads to infinity.
all